In the world AI, you think who is person holding power real? Is OpenAI with ChatGPT? Is NVIDIA with GPUs divine? Or is Apple, Amazon, Google giants data? Not. The answer lies in a town small, peaceful in Netherlands, where a company named ASML is secretly controlling door leading to future of industry semiconductor. They not produce chips, they not own AI, but not one chip AI advance from NVIDIA, Apple, Samsung, or even TSMC can be produced if without machine that ASML builds. Name of it is what? High NA EUV, machine worth 400 million US dollars, giant more than bus double-decker, and precise to level one beam laser from moon can hit coin on Earth. This is not just a machine, it represents the cutting edge of global tech leadership. Join with Top 10 Discoveries official explore why High NA is likened as machine-dominating era semiconductor post-Moore. ASML's technology has given it a significant lead in advanced lithography, an edge that is extremely difficult for others to replicate. Today, global players including the US, China, Taiwan, and Europe are accelerating their investments in semiconductors to shape the next generation of innovation and secure their positions in this vital industry. This no longer is a story about technology. This is Order Power Century 21, printed by Light. In world of intelligence artificial, where each millisecond processing and each watt electricity consumed all can decide who reaches finish first in race technology, High NA not only simply is one upgrade technical, it is breakthrough, is strategic asset, shaping again entire chain supply AI global. If you are seeking thing determines speed, cost, and ability development of models AI generation new, then that is High NA. At center of leap technology, this is one parameter seemingly modest, numerical aperture, NA. In generation EUV old, value NA stopped at level 0.33, but with high NA, number this is raised to 0.55. One change small in theory, but leads to one jump tremendous in practice production chip. This helps increase resolution image up to 70%. Result is transistors. Parts constituent forming brain of every chip, now can be printed smaller, placed closer together, and important most, more. Specifically on same area wafer silicon, engineers now can engrave additional to 60% quantity transistors. This opens space completely new for design chip AI, more cores processing, ability process, data large faster, and pass transmission internal shorter, helping reduce significantly latency and level heat emitted when operating. But not only that, one benefit significant other, and perhaps is important most in era energy, that is ability save electricity. According estimates, technical current, efficiency energy of chips produced by High NA can be improved up to 30%. Say way other, High NA not only helps models AI run faster, it makes cost training cheaper, amount electricity consumed less, and productivity production chip higher. This not is one improvement technical simple, this is one change strategic. It is key to open wave AI generation next, where performance, scale, and sustainability no longer are choices trade-off mutual, but together coexist on same platform technology. To achieve ability, engrave billions transistors with precision surpassing limit of eye human. High NA not only is one machine printing, but is one marvel technology. Precision that it achieves lies at level under 1 nanometer. Imagine this, as if you shine one beam laser from the surface of the moon and hit one coin placed in the middle square of Times Square. That is level that High NA is operating, but how to achieve things seemingly unimaginable that. First is one machine creates Sun Mini. Each second, have to 50,000 droplets, tin molten shot out in chamber vacuum. They immediately are by 4 beams, laser CO, 2 power, extremely large, heated to temperature, over 220,000 degrees Celsius, hot 10 times core sun, to create plasma emitting light EUV at wavelength 13.5 nanometers. That is type light only can engrave lines finer than molecule DNA onto layer photoresist on silicon. But light EUV has one weakness. It is absorbed nearly by everything. No lens can transmit it. No mirror ordinary can reflect it, except one type only, and that is place mirror Zeiss steps in. Each plate mirror is ground with error only few parts million micron, flat to level unimaginable. To understand easier, if you enlarge plate mirror Zeiss up by area country America, roughness maximum on surface of it, not yet equals height one blade grass. Plates mirror, those are tool only can navigate beam EUV through system, bend light ultraviolet super to position correct, time correct, angle illumination correct. All things these only to achieve one goal only, print out each layer, transistor thick, few atoms. Repeat process that over 100 times on one wafer to create brain of chip's strongest planet. In industry production chip, precision not only is factor technical, but is factor vital. And because that, before High NA appeared, factories semiconductor force must use to one strategy complex, multi-patterning. With each layer, structure transistor super small on one chip, instead only print one time, system EUV generation old must engrave repeatedly from 2 to 4 times, each time use one mask different to achieve resolution needed. Each time repeat like that means time slower, cost higher, and risk error increases by power exponential. But with ability resolution superior thanks aperture numerical, ANA larger, High NA allows engrave precise right from time first, one step print, one result. That pulls follow one chain effects positive. Quantity masks reduced means time production reduced. Number steps alignment reduced means error reduced. Rate products defective reduced leads to profit increased. And number evidence cannot clearer. Intel says they can shorten time production chip to 60% when use High NA. In context race, AI is heating up each hour, with companies pour billions USD to train model large. Ability bring chip new to market earlier few weeks, even few months. No longer only is advantage. That is survival. High NA not only engraves transistors, it also shapes the future of industry semiconductor, where speed, precision, and efficiency production are connected in one cycle, seamless, never before. Not coincidental that entire world semiconductor is holding breath each time one machine, High NA, is put into operation. This no longer is one device. It is one work engineering scale national. Each system, High NA, has price up to $400 million US, expensive more than one Boeing Dreamliner. It weighs from 150 to 165 tons, divided into hundreds modules, transported by 7 planes Boeing 747 and over 30 trucks. Not yet mentioned must reassemble an environment clean more than room surgery, where each particle dust also enough to distort measurement level nanometer. Precision under N nanometer, equivalent shoot laser from moon to hit coin on Earth. Power, 200 wafers each hour, operate 24/7, 365, produce millions wafers each year. Each wafer contains billions transistors, is material raw of world AI, and still not end. 2,000 connections electric, over 100,000 components, 40,000 screws assembled by hand and robot in factories super clean, under supervision of engineers top from Europe, America, and Asia. This represents the pinnacle of industrial engineering, where physics, optics, mechanics, chemistry, and software converge at an unprecedented level. But what truly sets High NA apart isn't just its cost or technical specifications. It's the depth of expertise and integration behind it, which remains unmatched in the global tech ecosystem. It lies in ecosystem that world only has one version only. Zeiss Company Germany is unit only on Planet Ken manufacture mirrors EUV. Plates mirror super flat to level if enlarged by size of America, then error curvature not yet to 2 inch. ASML Company Netherlands is enterprise only has ability to integrate entire chain technology. From laser CO2, plasma tin, mirrors reflective, engines nano, to system vacuum complete. Entire system, this needs over 40 years R&D, over 2,000 patents, and over 800 suppliers spread across 16 countries. One network industrial has precision, sophistication, and costliness top world. This no longer is one product commercial, it is strategic national asset. And in era AI, that is right lead in future technology. Since 2018, nearly every chip manufactured below the 5 nanometer threshold, from NVIDIA's GPUs to Apple's iPhones, whether by TSMC or Samsung, has relied on one critical enabler, ASML's EUV lithography systems, not because America or EU forces, but because no company other on Earth can make this. ASML currently owns over 2,200 patents only for EUV, covering entire chain technology, from plasma tin, tube optic EUV, system mechatronics superspeed, to software control oscillation nano. Thing notable is, no part in chain, this is plug and play. Components, though by suppliers different manufactured, are co-designed, tuned, tested together in many years. Even with access to technical blueprints, they will not can assemble or operate it because only ASML holds secret soft, process optimize, calibration, model physical. This is moat technology, not by law ban, but by intellect accumulated. ASML not simply is one manufacturer machine engraved chip. They are conductor of one orchestra technology global, where each part, each beam laser, each plate mirror, all come from partners unique, spread across 16 countries. That not is one chain supply traditional, but is one network neural distributed, where every cell together oscillates with rhythm of one machine only. At Germany, Carl Zeiss SMT provides mirrors reflective light EUV, type mirror flattest that human ever manufactured, to level light 13.5 nanometers newly not absorbed completely. Also from Germany, Trumpf provides laser CO2 power extremely large. Enough strength melt each droplet tin at speed 50,000 times per second to create plasma. Source light EUV. In America, MKS Instruments undertakes system emit wave, RF power high, control process ionization, sophisticated in environment vacuum. And at Japan, Mitsubishi provides materials ceramic superheat resistant, used in points contact that only exist few parts million, second under temperature exceeding 200,000 degrees Celsius. And right at homeland Netherlands, hundreds SME, enterprises small and medium, play role backbone. Manufacture components specialized to level, no name common, from system adjust pressure local to ensure stability at scale atomic, to robots operate in environment vacuum level 10 to the power of -6 atmospheres. Clean more than chamber transplant gene. This is one structure symbiotic absolute. One change in module frequency high in America can make must redesign lens in Germany. One improvement software in Netherlands requires tune again process measurement of mirror at Zeiss. ASML not owns all, but they coordinate all like one brain collective global. And that's why even with vast capital investment, no single nation can easily replicate ASML's model. It's not just about assembling parts or hiring talent. ASML represents a deeply integrated ecosystem, shaped by decades of co-development, collaboration, and a unique organizational mindset that's extremely difficult to reproduce. Thing that majority world not knows is, from year 2000 to 2018, technology EUV, thing makes foundation for entire era chip modern, nearly as one gamble failure. No source light EUV enough strong to create wavelength 13.5 nanometers. No material can reflect light that, which absorbed by nearly everything. Not exists chamber vacuum enough large to contain one system size like one bus, but must clean more than room surgery. Scientists doubted, competitors abandoned, but ASML still continued, poured billions euro into thing that majority world physics called impossible. This isn't just a story about technology, It's a testament to long-term strategic commitment built over decades. It's the kind of deep-rooted expertise that even well-funded startups would find extremely challenging to replicate. Because beside vision, ASML also had Intel, TSMC, Samsung. Customers not only buy machines, but also invest capital, provide feedback technical, and invest dozens labs throughout 20 years only to keep Dream EUV not frozen. Story that cannot repeat. In world AI, where speed training increases by each nanometer, you cannot lose 20 years to pursue one technology outdated right when just start. And that is reason why they call ASML as Empire Clean. Not only because entire machine print chip of them operates in condition clean 10,000 times room surgery, but also because purity and mindset control value. From photon light directed precise to each part million nanometer, to electron forced move correct position on layer wafer, thin 0.7 millimeters, and further, shaping entire future industry, semiconductor global by each step print nearly invisible. When speak about race semiconductor global, people often focus into numbers stunning. Process 2 nanometers, hundreds billions transistors, or speed inferencing of models AI gigantic. But behind layer glamour technical that is one confrontation, strategic silent but fierce, between two models development opposite each other. One side is America. They have bet into pinnacle technology with High NA as card ace main. Since month April 2023, Intel has silently installed machine High NA first at Oregon, machine likened as machine print sophisticated most history humanity. This not only is step advanced technical, but is declaration. America is actively investing to remain competitive in the race semiconductor progressive. TSMC, manufacturer chip leading world, also is producing mass at Arizona, and likely will deploy High NA in year next to maintain capacity process 2 nanometers on land America. ASML, manufacturer only in world can create High NA, understands clear importance of market America. They not only provide machines, but also build center training High NA first outside Europe at State Arizona. Currently, ASML has to 8,500 employees on land America, operate at 18 offices, labs, and factories, include centers R&D at San Jose, San Diego, and line production at Connecticut. America no longer simply is customer. America is one part cannot separate of brain ASML. But if tomorrow one event political or strategic makes flow High NA slow down, whether America, center AI of world, can keep position number 1 without machines those? While America pours force entire into leap process, China adopts a different strategic approach. Not need advance into future, only need buyback past. Banned completely access with EUV, China shifts to hoard buy massively line machine DUV, deep ultraviolet, considered technology old. But DUV still can print chip process 7 nanometers if applied technique multi-patterning, meaning divide layer mask out and print many times to achieve detail desired. Already had time, 49% revenue of ASML came from China. One number makes entire industry startled. So goal real of China in game semiconductor is what? Not try surpass America at process 2 nanometers. Also not compete directly at technology EUV, where they are blocked both about equipment and materials. Instead, China chooses one path detour, but full calculation. Redefine efficiency chip, not by way shrink, but by way stack. Strategy 1. Leveraging DUV lithography with 3D chip stacking. Instead of focusing solely on shrinking transistors on a single layer of silicon, a process that depends on advanced EUV lithography in highly specialized optics, China is investing in stacking multiple chip layers to build vertically integrated systems. China not tries race in race horizontal, node smaller and an M less. They are creating one game vertical, where architecture system important, more technology print simple. Technique this called is 3D stacking. Each layer silicon printed by technology DUV, then linked with each other by connections vertical micro. Result is what? Efficiency processing still increases, even faster, without need-touch technology EUV. This isn't just about making chips smaller, it's about building upward. Strategy 2. DUV lithography, combined with advanced packaging techniques. If cannot surpass limit physical of light, so why not change mindset? China is investing strong into technologies packaging advanced, where many chips can be placed beside each other in one package and communicate super fast through connections, silicon interposer, or technique wafer-level packaging. Say way other, increase efficiency not by transistor, but by architecture system. This is way that companies like Tianshu Jixin or Huawei are optimizing performance AI on process old. In this context, DUV systems now hold renewed strategic value, not only because China is still permitted by it, but because thanks machines DUV these, they can proactive produce chips 7 nanometers or higher, then combined by 3D stacking to achieve efficiency equivalent 5 nanometers or lower. In articles analysis about industry semiconductor, ASML often described as supplier equipment exclusive. But if only stop at roll manufacturer machines, we will miss one reality deeper. ASML not only sells machines, they coordinate entire order industrial chip global. Start with one number, seemingly technical pure. Each machine high NA contains over 40,000 bolts, 100,000 components, produced at least 4 countries, include America, Netherlands, Germany, and Japan. But assemble is not enough. Only ASML can assemble, calibrate, test, disassemble, and transport machine this one-way precise and correct time. Important more, no country, even America, can self-operate machine high NA if lack ASML. Reason is what? First, about manpower. Team engineers must undergo training 12 to 18 months, understand clear to each module, each protocol control, and each limit operation. Second is story infrastructure. Room clean meets standard ISO class 1 to 5. Clean thousands times compared room surgery medical is condition mandatory for machine operate precise. And finally is software calibration exclusive. No license, no update. Machine becomes box iron price 400 million USD cannot operate. This creates one state special. Countries like America, Korea, Taiwan, though own machine high NA, still depend direct into ASML to operate, maintain, and upgrade. Some experts once likened that ASML like OPEC of industry semiconductor, but instead control material, like oil, ASML controls capacity production semiconductor advanced, meaning ability print chip modern. Dependence this has two sides. Advantage strategic, country which has right access into machine A, SML, especially high NA, will keep position leading in industry AI, HPC, and defense digital. Risk dependence. But if chain supply interrupted, engineers not updated software, or components replacement delayed, entire line chip can stop operate. Therefore, ASML not only is supplier, but is point center of network semiconductor global, where every power grade all is customer, but no one is master real. In Century 21, power no longer lies at place exploit material, but lies at place. Controls each photon light printed onto silicon, and that is place ASML is standing. When high NA only just starts deployed scale large, ASML has silently prepared for step next. Hyper NA, one machine even larger, precise more, and costly more. Expected launch in 2032 to 2035, Hyper NA has numerical aperture surpassing NA equals 0.55 of high NA, aiming processes under 1.5 nanometers, one level that until now still is hypothesis physical. Cost can up to 700 million US dollars per machine, not yet count infrastructure, room clean, manpower, and maintenance. This will be equipment industrial expensive most ever manufactured, calculated by each unit. But question larger not is can do not, but is should do not. When each layer engraved chip becomes complex exponentially, efficiency economic by Moore's law starts slow down. At one point some, maybe 2 nanometers, maybe 1.4 nanometers, Cost each process smaller will no longer bring profit equivalent. So who will dare be person first bring Hyper NA into production? Intel, currently leading deploy High NA at Oregon. TSMC with ambition, keep Throne King production chip advanced? Leave comment below, we very want hear perspective your. Don't forget, like, share, and subscribe. Top 10 Discoveries Official will still return with discoveries, stunning, projects grand, and stories untold from everywhere on world. Goodbye and see you again.